I'm Stephane Fouquet, the facility manager of the imaging facility at the Institut de la Vision in Paris. The research of my facility will be much more oriented to brain and retina. So it's the Institut de la Vision. We are doing live imaging, we are doing fixed tissue imaging on Confocal, it's light imaging. Confocal microscopy, spinning disc, and we also do a lot of light sheet microscopy. So my interest on the microscope will be directed through the support and the capacity of the microscope to answer to the question of the researcher, which I'm dealing with. So the more important for them is to get a fully functional microscope every time. So I will be very, very interested by the support answer from the manufacturer, and then to get the best microscope working. So the best feature of the microscope will be detection of very weak signal and try to improve it, and then to make sure that what we are imaging is not false positive. And we need sensitivity and confidence. The cell culture or the preparation of the fluorescent matter will be very, very important for us, because if you have a bad material, you won't be able to get nice imaging. So that's why it's important to get something fluorescent. And the live, if you are doing live imaging, for example, in order to follow it, you need to be able to follow it. So you need a nice fluorescence expression on your cells or on your tissue to get the more beautiful pictures, and then you can get information afterwards. How the equipment of the facility is helping research and researcher because they are answering to their scientific question. So if you are questioning about how cells is moving, why or where, you need to have a nice microscope that is able to follow it through the time. If you are interested in development or description, you need to be able to do large view and zoomed view, and with nice picture in order to have enough information to describe the architecture or the tissue itself, and then explain how it goes, how it is developed through the time. We are doing a lot of development, and we have also a lot of light sheet imaging. So here you talk about large sample, very large sample. So that means that you are not considering the cell culture, the cell itself or a part of the tissue, but the whole tissue or the whole organ or the whole animal itself. So it's much more interesting to get a large overview and to be able to describe it. The Olympus microscope, we are using confocal microscopes. We have 3 confocal microscopes. It's a FV1000, FV1200, and I hope another FV3000. We are using the confocal microscopy in order to describe or to analyze how the system, the biological system is working. Since we are interested in development, we want to know how the brain or the retina, for example, will develop from birth to adults, for example. The benefits of the Olympus microscope will be detection, sensitivity, and now it's going faster. So it's very useful for us to be able to produce much more images and much more nice images, actually. So we are going to faster and more sensitive imaging. So I'm really interested in the new setup that they produce, the FV3000. It's very exciting.